So the unit circle is very useful for knowing sines and cosines of all those good angles. However, last year in pre-calc, you also talked about some other trig functions: tangents, cotangents, secants, cosecants. You saw a couple different ways of defining them, but there are identities that let us rewrite all those other trig functions in terms of sines and cosines, which is where our unit circle then will come into play for the other trig functions. The tangent of theta is the sine of theta over the cosine of theta. The cotangent of theta is the cosine of theta over the sine of theta. The secant of theta is 1 over the cosine of theta. And the cosecant of theta is 1 over the sine of theta. And the point is, we can use just sines and cosines to figure out the tangent, cotangent, secant, or cosecant of any angle around the unit circle. Let me show you a few examples. First one, I want to do the tangent of 5 pi over 6. Well, the tangent is the sine over the cosine, so I'm going to say, let's do the sine of 5 pi over 6 over the cosine of 5 pi over 6. And we then go to our unit circle. 5 pi over 6, that's the angle over here. The sine of this angle, sine is the y-coordinate, the sine is going to be 1/2. Cosine of this angle, cosine is the x-coordinate, you're going left and you're going as far as you can, that's not -1. I think our cosine is going to be -√3 over 2. Therefore, the tangent is going to be 1/2 over -√3 over 2. Now, obviously, that's not okay. We can't leave fractions inside fractions, so I'm going to simplify this. Well, this is like 1/2 divided by -√3 over 2. I hate dividing fractions. I'd rather multiply by the reciprocal, so I'm going to say times 2 over -√3. That's kind of nice. The 2's cancel. I've got -1 over √3. Let me rationalize my denominator, so times √3 over √3. I'm going to get -√3 over 3. And that's the tangent of 5 pi over 6. Next one. Let's take a look at the cotangent of 3 pi over 4. According to my identity, the cotangent is, sorry, I shouldn't say cotangent, I should say the cosine of 3 pi over 4 over the sine of 3 pi over 4. Let's find it. 3 pi over 4, that's this one right over here. The cosine is the x-coordinate. Moving to the left. I think that looks like -√2 over 2. The sine is the y-coordinate. I think that's +√2 over 2. So we can say this is -√2 over 2 over +√2 over 2. I could again multiply by the reciprocal, but I think I see these √2 over 2's are just going to cancel, and this is just going to be -1. The secant of 5 pi over 3. The secant of 5 pi over 3 is the same as doing 1 over the cosine of 5 pi over 3. So all we need to do is find our cosine. Okay, well, 5 pi over 3, that's the angle over here. Cosine of this angle is the x-coordinate. I'm moving to the right, the shortest amount that's not 0, so I think my cosine is going to be 1/2. I'm getting 1 over 1/2. Or 1 over 1 times the reciprocal times 2 over 1. The secant of 5 pi over 3 is 2. One more. Cosecant of pi. Well, this is 1 over the sine of pi. What's the sine of pi? Well, the sine is the y-coordinate when we get to pi. Here's pi. What's my y-coordinate over here? My y-coordinate is going to be 0. So the cosecant of pi is 1 over 0. Please don't tell me that's 0. 1 divided by 0, you can't do that. This is undefined. The cosecant of pi is undefined. I would very, very highly recommend that you spend some time taking a look at that delta math practice, just to get a lot of practice with sines and cosines and these other trig functions of these good angles around the unit circle. This is a pretty important thing, and again, something we'll be using all year long.